The Great Divide in the Skies, Boeing versus Airbus and a Century of Aviation Philosophy. For over a century, the skies have been the arena for an enduring rivalry between two aerospace titans, Boeing and Airbus. While both companies have propelled humanity into the age of mass air travel, their approaches to aircraft design, particularly concerning flight control systems, have charted distinctly different courses. This article delves into the divergent philosophies of these industry giants, exploring their historical evolution, technological innovations, and the profound impacts on pilots, passengers, and the economics of flight. Boeing, with its roots stretching back to 1916, has a long lineage of aircraft that evolved from mechanical marvels to hydraulic powerhouses. Its design philosophy has historically emphasized direct pilot control, believing that the human in the cockpit is the ultimate authority and safety net. This ethos matured through iconic aircraft like the 707, 747, and later the 737. Airbus, a European consortium founded in 1970, emerged into a more technologically advanced landscape. Free from the constraints of legacy systems, Airbus embraced a clean sheet approach, leveraging nascent computer technology to redefine aircraft operation. This led to a philosophy centered on automation, standardization, and electronic flight envelope protection. The core design philosophies, pilot as king versus computer as guardian. At the heart of the Boeing-Airbus rivalry lies a fundamental difference in how they envision the interaction between pilot and machine. Boeing, the pilot is king. Approach. Boeing's philosophy traditionally advocates for the pilot's ultimate authority over the aircraft, while integrating advanced automation and fly-by-wire FBW systems in newer models like the 777 and 787. Boeing ensures that the pilot always retains the ability to override automated systems and directly control the aircraft's primary flight surfaces. This is embodied by the traditional control yoke, which provides tactile feedback mirroring control surface movements. Airbus, the computer as guardian approach. Airbus pioneered the widespread use of full authority fly-by-wire in commercial aviation. Its philosophy posits that computers can manage the aircraft's flight envelope more precisely and safely than human inputs alone. The side-stick controller, which offers no direct mechanical linkage or force feedback from control surfaces, is symbolic of this approach. The computer intervenes to prevent pilots from exceeding aerodynamic limits, ensuring flight within a protected envelope. Flight control systems, a deep dive. 1. Airbus's fly-by-wire FBW with electronic flight envelope protection. Airbus introduced full authority digital fly-by-wire FBW with the A320 in 1987, a revolutionary step that has since become standard across its entire commercial fleet. A320 family, A330, A340, A350, A380. Technology. Instead of mechanical cables or hydraulic lines, pilot inputs via a side stick are sent as electronic signals to flight control computers, FCCs. These computers interpret the commands and then send signals to actuators that move the aircraft's control surfaces. Electronic flight envelope. Protection. This is the cornerstone of the Airbus FBW system. The FCCs continuously monitor flight parameters and prevent the aircraft from exceeding its aerodynamic or structural limits. Examples include alpha floor protection. Automatically increases engine thrust if the aircraft approaches a stall, angle of attack. Pitch attitude limits, prevents excessive nose up or nose down angles. Bank angle limits, restricts roll angles, typically to 67 degrees in normal law, automatically returning to 33 degrees once the stick is released. Overspeed protection prevents the aircraft from exceeding its maximum operating speed. Load factor protection prevents excessive G-forces. Operating modes. Airbus FBW has different laws or modes. Normal, alternate, direct, that degrade protection levels in case of system failures. But in normal law, the pilot operates within the computer's watchful eye. Standardization. Airbus cockpits across different aircraft types are remarkably similar, allowing for common type ratings for pilots, e.g. A330, A340, or A350, A380. Boeing's traditional systems and evolution to partial FBW. Boeing's lineage from the 707 through the 747 and 737 relied heavily on mechanical and hydraulic systems. While modern Boeing aircraft 777, 787, 747, 8 incorporate advanced FBW, their design retains the philosophy of direct pilot authority. Technology. Early Boeing aircraft used mechanical cables and pulleys, e.g. 737 Classic, or hydraulic power-assisted controls, e.g. 747. Even with FBW in the 777 and 787, the system is designed to mimic the feel of mechanical controls. The pilot uses a traditional control column yoke that provides tactile feedback. Pilot intuition and control. Boeing emphasizes that the pilot should always be able to directly command the control surfaces. While automation is extensive, the pilot can always overpower it. There are no hard envelope protections in the same sense as Airbus. Instead, warnings and cues guide the pilot, but the pilot ultimately decides. Control column yoke. The yoke provides physical feedback, including movement of the other pilot's yoke, known as coupled yokes, and resistance that increases with aerodynamic forces, giving the pilot a direct sense of the aircraft's state. Evolution. The 777 was Boeing's first commercial aircraft with full FBW for its primary flight controls, ailerons, elevators, rudder. The 787 built on this. However, unlike Airbus, Boeing's FBW systems are designed to emulate conventional controls, offering soft limits and pilot override capabilities. The 737 MAX's maneuvering characteristics augmentation system, MCAS, intended to assist with stall protection, represented a departure from this direct control philosophy and highlighted the complexities of blending automation with traditional design. Impact analysis of divergent philosophies. Pilot training and workload. Airbus. Pilots learn to manage automation effectively. Training focuses on understanding system logic, monitoring, and problem solving within the protected envelope. The side stick demands less physical input. Commonality across Airbus types simplifies training and transitions for airlines. Boeing. Training emphasizes traditional manual flying skills, direct handling, and nuanced control inputs. Pilots are trained to understand the aircraft's limits and to manually intervene or recover from unusual attitudes. The physical feedback from the yoke and rudder pedals requires more direct engagement. Airbus. The electronic flight envelope protection aims to prevent stalls, overspeeds, and structural overstress, reducing the risk of accidents caused by pilot error in extreme situations. This can lead to smoother flights and greater consistency in operation. Critics, however, point to concerns about automation complacency and pilots losing manual flying proficiency. Boeing. The emphasis on pilot authority allows for greater flexibility in unusual situations, trusting the pilot's judgment to push limits if necessary, e.g. in extreme wind shear. However, this also means the pilot can inadvertently exceed structural or aerodynamic limits. The 737 MAX incidents underscored the critical importance of transparent automation and pilot understanding when new systems interact with traditional control philosophies. Passenger experience. Airbus. Flights can often feel smoother due to computer-smooth control inputs, reducing abrupt maneuvers. Passengers generally experience consistent ride quality. Boeing. While cabin design, seat comfort, and noise levels are more significant factors for passenger experience than flight control systems. The absence of hard envelope protection in some Boeing models could theoretically allow for more abrupt maneuvers, though highly skilled pilots typically avoid this. Maintenance and operational costs. Airbus. FPW systems reduce the number of mechanical components, cables, pulleys, potentially simplifying some maintenance tasks and reducing weight. The high degree of component commonality and standardized cockpits across different Airbus models can lead to lower training costs and spare parts inventories for airlines operating a mixed Airbus fleet. Boeing. While its FPW systems are also sophisticated, the blend with traditional components means a mix of mechanical, hydraulic, and electronic maintenance. Boeing's wider range of aircraft models with less cockpit commonality historically meant more varied training and maintenance requirements, though newer generations are improving standardization. Trade-offs: security, pilot autonomy, and the flying experience. The fundamental divergence boils down to a trade-off: security. Airbus, prioritizing safety through computer intervention and hard limits. This reduces the possibility of human error, leading to catastrophic events, but might limit the pilot's ability to react instinctively in unforeseen circumstances that fall outside the computer's programmed responses. Pilot autonomy. Boeing, prioritizing the pilot's ultimate control and judgment, believing that a skilled human is the best problem solver in truly novel situations. This places a greater burden on pilot training and real-time decision-making. The flying experience also differs. Airbus pilots often describe a point-and-shoot sensation, where the aircraft smoothly executes the desired trajectory. Boeing pilots often speak of a more direct tactile connection to the aircraft, where they feel the airframe's response. Airbus A320 family, A319, A320, A321, the pioneer of full FPW with envelope protection. It revolutionized short to medium haul flight with its highly automated cockpit and side stick controllers. Airbus A380, the super jumbo jet, a testament to Airbus's FPW philosophy, integrating highly complex systems under the control of sophisticated computers, all managed via standardized Airbus cockpits. Boeing 737, a workhorse that began with purely mechanical controls and evolved with hydraulic assistance, yet maintained the yoke and direct control philosophy throughout its many generations. The MTS system on the 737 MAX, intended to mimic handling characteristics, inadvertently caused a conflict with the traditional pilot is king ethos. Boeing 777, Boeing's first true fly-by-wire aircraft, yet it was meticulously designed to feel like a conventionally controlled aircraft. The control yokes remain linked, and pilots can overpower the flight computers, showcasing Boeing's commitment to pilot authority even with advanced technology. Boeing 787 Dreamliner, an advanced FPW aircraft that further integrates computer control but still adheres to the core Boeing philosophy of pilot override capability and traditional controls. The ongoing evolution and convergence. In recent years, a subtle convergence has been observed. Boeing's newer aircraft integrate more automation and sophisticated flight management systems, while Airbus has introduced certain enhancements that give pilots more direct control in specific failure scenarios. Both manufacturers are constantly striving to balance the benefits of automation with the irreplaceable value of human intuition and judgment. The century-long journey of aviation innovation, particularly evident in the contrasting philosophies of Boeing and Airbus, has shaped modern air travel. Boeing's legacy of pilot authority and direct control stands alongside Airbus's pioneering spirit of automation and electronic protection. Each approach has its merits and trade-offs, driving continuous debates about the optimal balance between human and machine in the cockpit. As technology advances, the conversation will continue. But the indelible marks left by these two giants on aircraft design and flight control systems will undoubtedly continue to influence the future of aviation.